Hello, this is Coach Myanmar for AP Pre-Calculus. We're just going to do some extra lessons here. We're going to finish up doing our extra lessons on using the derivative and really what it represents. So the derivative is just a fancy word for slope. That's all it is. So the slope of a tangent line of a function called the derivative of x can be noted as f prime. So f prime is this thing right here. We're talking about limits. And I do want to kind of get into what the heck this is even talking about. Okay, what this really is, is this is going to be related to y2 minus y1 over x2 minus x1, but this is using this for function notation. Okay, it's just the slope. Now, what we're used to is this f of b minus f of a all over b minus a. Now, what if we're looking at this and we're trying to minimize the distance between b and a? So let's say that I have some function like this, and let's pretend like I hit the zoom button. So here's the zoom button. It's right there. Zoom button like 18 times, and I'm really, really zoomed in here. And I want to find the derivative function of this just by looking at 2 points. Okay? So what we're going to do here is we're going to look at, let's call this right here. This will be x f of x. Whatever that height is right there, f of x. And this distance right here is h, which means that this right here would be f of x plus h, because we're just going over, well, you know what? If I want to do plus h, I better go to the left. Hold on. Redo. This didn't happen. Let's call this f of x. And this is f of x plus h, which just means I went left h values, okay, from f of x there. Okay, if I'm trying to find the rate of change of this, okay, I'm going to do f of x plus h all over f of x, okay, all over h, which is the change in x. Okay, I feel like I've been confusing more people. I'll tell you what, I think I got a little better job. Let's do f of delta x. Delta x represents change. So how much am I changing of x? Okay, minus f of x all over delta x. Okay, it's kind of sort of what we're looking at here. So we're just trying to look for this very, very, very tiny amount of change because we have h is approaching 0. So we're saying that our change there from the function to the next thing is very, very, very tiny. If you're like, oh my gosh, I don't know all this, for right now, we're going to kind of table that discussion. And I'll just demo it real quick with Desmos after I do this first example. What we're going to learn here is just the power rule to kind of get away from this limit definition. You'll do that in calculus. We'll just talk about it a little bit here. So here's the theorem that says that if fx is a constant and we take the derivative of the constant, we get 0. Makes sense because we're just derivative is slope. Slope is rate of change. So if we have the slope of a constant value is 0. Makes sense to me. Then we have something called the power rule, which is theorem 2 right here. Okay, so all you do is you just take the nth power and multiply it by the coefficient and then subtract 1 from the power. And you can do that if something is adding or subtracting. Theorems 3 and 4 just kind of build off of that one. You'll see it right here. So we want to find the derivative of each function here. So the derivative of this, which should be f prime, we have to use power rule. Means we're going to take that 2 and multiply it on the 12 and get 24. And subtract 1 from the 2 and get x. Okay, this is a 1. Multiply it by the 4, you're going to get 4. So minus 4. And then the x to this 1 becomes x to the 0, which is just 0. And then the derivative of the 7 is going to be just a 0. So this derivative becomes a 0. So my derivative function is this right here. Okay. Now what I'm going to do is I'm going to quickly go over to Desmos. Here's this function right here that was on this problem. Okay. That is in red. I'll undo this one. So this is red. So we can clearly see that this is this function. And we know the answer is 24x minus 4, which is a line. Okay. What I did here was I just typed in f of x plus a minus, you know what? If you want h, I'll do h. So it's all consistent. And I'll make this a slider for h. There you go. So I'm doing the steps really, really tiny. I'll just look from 0 to 2. And you can see that when I have a large function here, I'll make this blue now. So here's the function. As I get, is this h value, is that distance between the x's, the change in x's get smaller and smaller, that function is going to get closer and closer to lining up with this value right here. Pretty much as close as we can right there, which is 24x minus 4. As you can see right here, the b value is -4. Okay, and I can do the same thing when I'm looking from -2 to 0. As we're getting values that are getting closer and closer to 0, you can kind of see how those two would be lining up. Okay, can I make another slider for h? I don't know how to make a slider. Oh boy, I should do this ahead of time. Like 0.13. I can't do it at the same time. Ooh, know what I can do? You just bear with me. I'll just use A now. So we can look at the left and the right, and we can see their matchup. Add a slider. We'll do the same thing. And then we'll go from 0 to 2. Okay. So you can kind of see how these, one's purple, one's blue. See how this one's getting closer and closer over here, and this one's getting closer and closer over there, and they're going to match up together. They're going to overlap. Looking at the limits from the right and left side, they're going to overlap right about here-ish, which is going to be this 24x minus 4. All right. You can always Google what this definite derivative means. Okay, so we're just looking for the derivative function. So let's go ahead and find f prime here. So f prime of x is equal to, just take that 4 on top of that 3 becomes 12. X subtract 1 cubed minus 2 on top of that 7 gives you a 14x to the 1 minus, take that 1, put it out in front, just becomes 1. And then the -1 becomes a 0. And that's the derivative function, which represents rate of change. I'll get to that meaning in just a minute here and what that can do for us. Let's go backwards. If I have 5x to the 4th, what is a possible derivative to have for this? This is already giving me the derivative. So if I go backwards now, what would this be? So the answer, it's like Jeopardy. The answer is 5x to the 4th. What's the question? So what's the function? Well, if we usually first multiply in front, probably should do the complete opposite and divide. Okay, so this would be the same thing as dividing this by by a 5, so it becomes x to the 5th. Okay, does this check out? Does this derivative work? Derivative of x to the 5th is 5x to the 4th. Just a little bit of guess and check. What if I have this as an answer? Is this also correct? Because what's the derivative of 1? It's 0. Is this number also correct? Yes. Is this number correct? Yes. Is this number correct? Yes. If I can just keep adding numbers. They're all correct because the derivative of all those constants are 0. So I will... I'll just say plus c, where any constant represents c. Okay. All right. Let's go to our last page here. So now I'm going to go ahead and graph this function. I'll go to the steps in just a second. So I'm going to give you a function here. And we're going to go through everything and kind of talk about what everything means here. So we're going to find the derivative, go over some things that the derivative tell us, and we're going to be using some sign charts and other things we've done in this class before. Okay. So step 1, find the derivative. So we're going to go ahead and graph this function first by finding the derivative. Let's go ahead and do this in blue. Okay. So f prime of x is equal to 3x squared plus 6x. You agree with that? Good, you better, because it's right. Okay, find the zeros of the derivative. What this does is this tells us when the slope is 0, because this represents slope. So when is the slope 0? Well, I'm going to factor out a 3x, leave me with x plus 2. And then I'm going to get x equals 0 and -2. Okay? So this is going to be, we call these critical points. All right, so we have slopes of 0 at x equals 0, -2. Let's make a sign chart. So now this derivative represents slope. So let's go ahead and make a sign chart of the slope. So I have at a 0 and a 2, my slope is 0. But if this is a parabola, it's an upward parabola as my end behavior. End behavior is there, and it's going to cut at 2 and 0, so change of signs. So what does this say? So I am increasing from -infinity to 0 and from 2 to infinity. I am decreasing from 0 to 2. Okay. I can get into whether or not we should include the 0 and the 2. I'm not going to get into that. So just for right now, I'll leave them open. Okay, find the coordinates of the extrema. What the heck does that mean? That means that I want to use my critical point. So I want to find f of 0 and I want to find f of 2. This is plugging back into the OG. If I plug that back a 0 into the OG, I'm going to get 0 cubed plus 3 times 0 squared minus 4 gives me -4. Plug a 2 back into this OG. I'm going to get 2 cubed plus 3 times 2 squared minus 4. I believe that gives me a 0. Okay. So these are coordinate points. These are my first coordinate points. I'm going to go ahead and plot those. And then 2, 0. Okay. Oh, you know what? It should be a -2. Oh my gosh. I was just looking like, wait a minute, something's wrong. Okay. Back up, back up. Beep, beep, beep. If I had the right coordinate points, this would be better. Hopefully you caught that mistake earlier and were like, oh, he's no clue what he's talking about. Well, I'm fixing it now, all right? We'll go from -2 to 0. There we go, fixed it. These coordinate points are still, no, these are off. This is at -2, which is 0. There we go, plug in a -2. I was just guessing. I thought it was 0. I looked at my notes. I got everything right now. Everything's correct. So if you plug in a -2, you will get 0. Okay, what are the actual zeros of f of x? So we're going to go ahead and, hello, I'm in here. Okay. Zeros of f of x. Well, first off, we can factor that. Well, we do know one of the zeros, right? Isn't one of the zeros just by happenstance here? It's -2. So can't we do long division to divide this out? So if I use long division, hey, look, this is a review for you. I can take out a factor, and then everything else should factor nicely for me. So I'm going to get x squared up here. X squared times x is x cubed plus 2x squared. And we're going to subtract that. And we're going to get x squared minus 4. All right. No, that just becomes, what am I doing? Yeah, x squared minus 4. Yes, okay. And then x goes into x squared, x times, so plus x. So I'm going to get x squared plus 2x, subtract that. And then I'm going to get, sorry, I'm running out of room. I'm going to get -2x minus 4. And then that goes in -2 times. And that checks out. So I subtract that, I'll be left with 0. So this is equivalent to finding the zeros. I already knew I had the x plus 2 factor in there. And then I have the, I have it right here, x squared plus x minus 2. And how does that factor? xx to 1, positive 2, negative 1. So that gives me zeros at x equals negative 2, which I already knew that. Yeah, and then 1. Okay, because that's a repeat. So at 1, I have a 0 right here. What's the y-intercept? That's just plugging in a 0 to the OG. So I'm going to get negative 4, which I already have that. I already found the y-intercept. And then end behaviors using limits. Okay, so let's remember how to do this. We're going to limit. This is going to be the right end behavior. All right. You can already tell from my chart right here, if I'm increasing up forever and ever and ever and ever, that's going to equal infinity. That's the right, by the way. I'm going to do left. This is an odd powered function, so it's going to be the opposite. So it's going to go down. Okay, and let's go ahead and graph everything. Okay, so all we need to know here is that since I have 2 zeros at negative 2, I'm going to bounce here from our graphing unit. I'm going to bounce there at negative 2 because I have zeros of negative 2, and that's going to be a multiplicity of 2. And everything's going to be a cut through. So we're going to start down here. And so we're going to increase until we get to negative 2, which we do. And then we're going to decrease until we get to 0. And then this is going to be a slope of 0 right there. And then we're going to go ahead and then increase forever and ever from there. Okay. So if you notice, you have horizontal tangents. Those are called horizontal tangents. Because our slope function equals 0 at those x values. So those are horizontal tangents. All right, and that's going to wrap up this video. Sorry, that was kind of a little sketchy right there. I promise I know what I'm doing. I don't promise that, actually. All right, don't forget to like and subscribe.